Hey everyone, hi. Welcome to the video. My name is Ankush, and in this video, we'll be looking at how does the internet work in general, and we'll be looking at some basics into it. So without any delay, let's just dive right into it. Okay, so before we understand how does the internet work, we should understand what is the internet first of all. So at its very basic, internet is the infrastructure such that it facilitates or it helps two or more computers to communicate with each other. Now, this is basically the infrastructure over which services such as the email or the web have been built. So we should first understand what is the internet first of all. How does it work? And then we'll go into the nitty-gritties of it. So again, as I said, at its very basic, it is a it is a system such that it enables or it facilitates the communication between two or more computers, right? Now, to make this possible, we need to connect them, right? Now, we need to connect them with the help of, let's say, wired technology such as the Ethernet or wireless technology such as Wi-Fi, Bluetooth, whatever it is. Okay, so uh, for the sake of discussion, we'll be making use of wired technologies in this discussion. But again, do remember that whatever we discuss is possible for wireless technologies as well. And all modern computers are capable of handling both wireless and wired technologies. Okay, so now to make communication between two computers possible, we can just directly connect them with the help of Ethernet or wireless technologies like Bluetooth, Wi-Fi, whatever it is. But such a network, let's say, if the number of computers scale up, let's say currently we have two computers, we just need one wire to connect with them. But let's say we have to connect 10 computers, or in the worst case, we have to connect all the computers in the world. Such a network becomes really, really cumbersome, right? You just see how many wires we'll be needing. It might looking like something this, because every computer has to be connected with every other computer. So this makes it very difficult. This makes it very, basically it's very difficult to handle. Just imagine you have to connect your computer to every other computer in the world. The wired wires will be a bit too much. Now, just to solve this problem, we make use of another computer, right? And that computer is known as a router, such that every computer is connected to the router, and the router has only one job. That is, it has to send the messages from the recipient to the destination. That's it, from the one who's sending to the one who's expecting the response or the message, whatever it is. Now, again, as the name suggests, router, it has just one job of routing the messages from the sender to the receiver, such that every computer is connected to the router. And router is just another computer. That's it. Such that it does the job of routing the messages, right? But still, every other computer has to be connected to it. But as we said, this is just another computer. Let's say we want to scale it to n number of computers. What we can do in that case? We can basically use different routers. One router can be connected to another router such that, let's say, in this diagram, I want to send a message from A to H. What can I do is I can send the message from A to the first router, which is directly connected to A. Now that router, since it finds that it is not directly connected to H, it sends the message to the router which is connected to H, and that router finally sends the message to H. Now, to scale this to, let's say, n number of computers, any number of computers, you can just connect different number of routers. That's it. That makes it very easy to you know collaborate or facilitate the communication between these computers, such that all you have to do is you have to connect different routers among together. Now, this is very close to what we call the internet, but we are forgetting one thing. This was how we started as a local network, right? We picked up our computers, we started connecting them. Now, since we cannot connect every other computer to every other computer, we connected them to a router, and every computer was connected to the router that we had in-house. But how do I send a message, let's say, all across the globe? I need to connect all the routers in the world, and then I'll have to physically connect them with the help of wires. Even if it's routers, it's still physically or practically impossible. So what do we do in that case? Now, we already have a network of wires or a network of connections between houses in the world, all the houses in the world, and that connection is in the form of electricity cables or telephone cables. right? So why don't we just make use of those existing wires or cables to make to use our use case? And that is exactly what we do. So for our use, we make use of the telephone cables, but telephone cables cannot send the messages by computers, send by computers. Now to do that, so that the telephone cables can handle that, we make use of a special equipment known as modem, right? Now the modem, it has the job of converting the messages sent by a computer or a router, which is again a computer itself, into a form such that it can be handled by the telephone cables, and reconverting them into the form such that the computers can understand, right? So now this whole flow becomes like you send the message to the router sends the message to the modem, and the modem converts the message into a format such that it can be sent over those telephone cables. And after that, after passing through the telephone cables, the message goes through another modem such that it reconverts the message into a format understood by the computer, and then the computer, which is the router, reroutes the message to the correct destination, right? Again, don't get too confused or too complex. It is just a flow. That's it. You send the message, it goes to the router. The router sends the message to the modem. The modem converts the message into a form such that it can be sent over those telephone cables. And then again, that goes through another modem such that it reconverts the message into a format understood by the computer. And then it is sent to the router again, which reroutes the message to the correct destination, right? Again. Now, this is something what we call as the internet. But now for this, we also need another thing known as the internet service provider. Now, what is the internet service provider? Now, at its very brief, internet service provider is just a company which has special kinds of routers such that these routers can, send messages to different routers, and they have access to other routers as well. That's the only job of the internet service provider, right? So it basically has, routers which can be used to send messages to different routers, just as what we do. So the overall flow becomes something like this. You send the message to the router sends the message to the ISP, the internet service provider. Now the internet service provider, with the help of modems and everything that we spoke about, sends the message to the another internet service provider which has a different router, which is accessible by the internet service provider that you send the message to, and that internet service provider sends the message to the router, which further distributes, or what you say, uh, redirects the message to the correct destination. Again, internet service provider is nothing but a company which has special routers such that they can access other people or other companies routers. That's it, right? So this is basically how what you call as the internet, right? It has, again, we'll just reiterate everything for the sake of simplicity. you know Now, just to facilitate communication between computers, we make use of a router, which is just a computer which has the job of routing messages from the correct source to the correct destination, right? Now, to connect or to make use of telephone connections that we have already built up, telephone cables, we make use of modem such that it converts the messages understood by the computer into a format such that they can be transferred over those communication cables or telephone cables, and again reconverting into a form such that they can be understood by the computers. And we also have the internet service provider, which basically is a company that has routers such that they can get messages from your network, and send them across different networks, and have access to other routers from different networks as well, right? This is the overall flow. Now, from understanding this overall flow, you must have got one question, that the router performs a very important job, that is redirecting the messages from sender to receiver. So every time you send a message, you need to tell the router that you have to send this message to this XYZ destination, right? So you have to identify that computer. So there comes a very important point. How do you identify different computers on the internet, right? How do you identify them? So to answer this, a bunch of people came together and they formed what we what we call them as the IP addresses, where IP stands for Internet Protocol. Now, this IP address is basically a unique ID given to a computer such that it can be identified on the internet. Every computer that is on the internet has a specific IP. Your computer must be having an IP address. Every computer in the world has an IP address, right? And they are prone to change. They can change a bit, but again, they are unique. Every computer is identified by its IP address. Now, how does the IP address look like? The IP address looks like something like this. It is a combination of four numbers, right? Now, every number can be represented by what we call 1 byte or 8 bits. So it is basically a 32-bit combination, 32-bit number, whatever you want to call it, such that this is used to identify computers on the internet, right? Now, there is another version of IP address just because we need them. Now, this is something known as IPv4, right? 32-bit addresses are known as IPv4, but since the number of computers have grown a lot in the last few years, we came up with another address known as IPv6. But the only difference is that it has a larger length. That's it. We won't go into much specifics of it because that is beyond the scope of this discussion. But it is quite similar to what we have in the IPv4. Just it is longer. You can say that, right? Very short description. Again, IP addresses look something like this. This is IPv4 address, 32 bits, so that we have four numbers. Each numbers can be represented by 1 byte or 8 bit, so 32-bit address. Okay. So every computer in the world has an IP address associated with it. But again, it is like it is like saying that I want to call a person Z. I have to remember its name every time. It is not possible, right? Whenever we came up with phone numbers and everything, it's not possible for you to remember every other phone number in the world. So what do? We came up with phone directories, right? We came up with phone directories. Similarly, on the internet, to identify, it's not possible for us humans to identify these numbers. It is perfectly fine for computers to identify, but it is not easy for us or not possible for us to remember this. So just like a phone directory, we came up with a database known as domain name server. Now, what is a domain name server? A domain name server is basically a database such that it maps every number to a human readable name. Now, what do I mean by human readable name? Let's say you go to your browser and type google.com. Now, what does that mean? That means that you want to access a web page from google.com. That is whatever it is, right? So you basically want to access the computer, you want to communicate with the computer which has a name google.com. Now, this DNS maps that google.com with a particular IP address such that whenever you type in google.com, it will give you the IP address of google.com such that you can be connected with that computer. Your message can be sent across to that computer and you can receive the correct response. Now, this is the job of the domain name service. It performs multiple services, but this is the primary job of a domain name service such that it maps a human readable name with the correct IP address, right? So whenever, let's say you do youtube.com, what you're doing, you're basically, typing in the name of youtube.com. It goes to the domain name server. It returns the correct IP address and then you're connected with it. So again, if you know the IP address directly, you can directly put it in the browser and you will be connected to, or you can see youtube.com. You can see a response from it or google.com, whatever it is, right? That is the easiest way to connect or to, basically access a website on the internet. But again, DNS, just because it is not possible for us to remember all these names, we came up with this service just like a domain names, just like we have the phone directory, right? We can easily remember names, we can easily remember google.com, but we cannot remember 173.194.121.32. We cannot remember that, right? So that's where the domain name server comes in. Now, this process of identifying the IP address with the help of the domain name, again, domain name is the human readable name given to that website, whatever the website you want to access. It is a human readable name given to that website. Now, this process is known as a DNS lookup, right? DNS lookup means you give the domain name server the domain name, and it returns the IP address. Now, the reverse of this is also possible. The reverse is such that You give a particular IP address and it returns the domain name associated with that IP address. Now, this thing is known as a reverse DNS lookup. Again, DNS performs multiple operations, but the primary job of DNS is to do this DNS lookup. You give a particular DNS, a particular domain name, and it runs the IP address associated with it. And again, if you have the IP address, you can directly access it. Okay, but again, we have a single database. So imagine all the people in the world accessing DNS at the very same time. This will make it very slow. This will make the internet very slow. On every time you type in google.com, let's say millions of people will be accessing google.com at the same time. So domain name server, it becomes very difficult for a single database, uh, to basically respond to all the queries that are coming in. Now, to solve this problem, we make use of something known as a cache. Now, what is cache? Cache is basically a temporary memory. Temporary memory, we'll talk about it, why is it temporary, but it is just a small temporary memory such that it stores the IP address associated with domain names temporarily, right? So whenever you type in, let's say, google.com on your browser, your browser basically checks it, before going to the domain name server, actually going to the DNS, it checks into these four caches. Cache, the browser cache, the OS cache, the router cache, or the ISP cache. We'll talk about it, what it is. But again, do remember that cache is just a temporary memory. Now, when you talk about the browser cache, you have the browser, right? So browser also maintains a temporary memory such that it keeps track of the IP addresses associated with some of the domain names that you have been using so far. So whenever you type in some domain name, before going to the DNS, it checks the browser cache and tries to find out if the IP address associated with that domain name is available or not. If it is available, it will give you the response instantly. If the correct IP address is not available in the browser cache, it checks into the OS cache. Now, OS cache, again, your operating system also maintains a cache such that it keeps track of some of the IP address associated with domain names. So the browser checks with the OS cache that is it available before trying to display it. Now, if it is not there, then it checks into the router cache. Again, your router also maintains some memory to access, to basically store some of the IP addresses associated with the domain names, right? If it is available there, it will display it. Otherwise, it goes to the ISP cache. Now, your internet service provider's cache also maintains a cache. If it is not available there also, then a DNS query or a DNS lookup is initiated and you get the query from the DNS, right? That's why, you might be seeing that if you visit a website very often, you can open it very fast. And the reason being that it is part of your browser cache, right? So a DNS query does not needs to be initiated in that case, or a DNS lookup, as I should say, does not need to be initiated, right? Again, this is a temporary memory, right? So based on your usage, this might change. Again, you can this can be programmed in different ways. One of the most common ways is to store the most recently used or the most frequently used domain names, put it in the cache and then use it, right? So this can be one thing. Again, it's just a temporary memory just to reduce the load on the DNS servers. This is used, right? Again, quite amazing, this technology, how beautifully this works. Again, so that is why a DNS lookup is actually very rare, because most of the times these four cache memories do the job. Okay. Now, before we move forward, uh, before we wrap up everything, we should understand the difference between a web page, a website, and a web server, because these are the three core elements of the internet, of the web in general, which is a service hosted on the internet, right? Now, even in our discussions, we are making use of we use of terms like a web page, website, and a web server. So what do they mean exactly? Now, a web page is simply a document that can be displayed on the browser. Simple, that's it, nothing else. A web page is a document that can be displayed on the browser, right? Now that document, it can have that document is, generally it is written in HTML. Now to add interactivity to it, we make use of scripts using some languages called JavaScript, and to add colors to it or to add some what you can a feel to it, we make use of CSS, right? We can also embed audios and videos to it. But again, a web page in very simple term is just a document that can be displayed on a browser, right? Now what is a browser? A browser is basically a software which can retrieve and display web pages. That's it, nothing else. Now, different web pages can combine together to form what do we know as a website, right? So what is a website? It is basically a bunch of web pages connected together such that they share the same domain name, right? They share the same domain name. Wikipedia is one very good example, right? You can see different web pages to it, but all of them share the same domain name, which is wikipedia.com. Then inside that you can basically move from one page to another, right? So every time, let's say you type wikipedia.com, you enter what you know as a home page, basically the main page, the first page that you see on the website, known as home or home page. But again, all the web pages inside the website, they are related such that the resources are shared and so on. But that's what a website is. A website is basically a bunch of web pages, related web pages, which are stored in a in a particular location together, and they share the resources, and you can basically access one web page from another, and so right. Now that is a website. Okay, but what is a web server then? A web server is basically a computer such that it it hosts it does the job of hosting a website. Now what does hosting a website? Hosting a website means all the resources related to a particular website, such that there can be audios, videos, all the web pages, and all the related resources such as audios, videos, whatever it is, they are stored on that computer. That is known as a web server, right? That is known as a web server. So this is what happens. Let's say you type google.com, right? Now the web server, which is basically the computer which is hosting it, the request goes to that computer, right? The DNS lookup might be initiated and everything. So the request goes to that web server. That web server sends in the response, which is basically the web page associated with it. It gets downloaded on your browser, and then it gets displayed here, right? So again, web server is basically a computer which does the job of hosting the website. Now, a single web server can hold multiple websites as well. So let's say whenever you're saying my website is not running, or my website is not, I cannot access my website, or my website is not responding, it is basically the web server which is not responding, right? That's why all the websites which are hosted on that particular web server, they are not accessible. They are not being displayed. That's it, right? Again, the problem is not with the website, it is just with the web server. It is not able to respond. That computer is not able to respond. Again, a web server is just a computer which has, which does the job of hosting the website. It can host more than one website at the same time. Okay. Now, another term which is very confusing on the internet is a search engine and a browser. Most of the times, people think that they are the same things, but again, they are not, right? A browser is a software such that it can display and retrieve web pages, whereas a search engine is a website which helps to find out other web pages, right? Google.com, Bing, Yandex, DuckDuckGo, these are search engines, whereas Chrome, Firefox, Safari, these are browsers. These are softwares which are used to retrieve and display web pages. But a search engine is a website which helps you find other websites. Now, the confusion can arise because whenever you open a browser, the first page or the first thing that you see is a search engine. Google.com, Bing, whatever it is, Yahoo, whatever it is, DuckDuckGo, whatever. But that makes sense, right? Whenever you open a browser, you will try to find other web pages, other websites to be displayed on the browser. But again, understand the difference. A browser is a software which can retrieve and display web pages, whereas search engine is a website which helps you find other websites, right? So at its very core, these were the elements of the internet. This is what makes the internet work. Hope you had some fun with this, guys. This is just the beginning phase of it. You can explore much more things. But again, these are the small details of it. Hope you had some fun. Thank you very much for watching the video. See you. Bye bye.